Hi, you guys. Today we are going to be playing with some cards, some that just have equations, some that have data tables, and some that have the graphical representation of exponential functions. So I want you to be able to fluently go from all three of these forms to the other. So let's take a look at our basic equation first. I'm not going to give you this, but I want to teach you how to create a data table from something like this. You would say X, you would say Y, and you get to make up values. Let's go -1, 0, 1, and 2. Those are some pretty standard values if you were to make a data table. So then we put this value into our equation, y equals 2 to the x power. Any 2 to the -1 power, remember, that negative would put this on the bottom. So that would be equal to 1/2. So our y is equal to 1/2. Now, if we were to do 2 to the 0 power, anything to the 0 power is just 1. So that's an easy one. And now let's do 2 to the first power. That's just 2 times itself, or 2 times 2, 1 time, so it's just 2. And then finally, 2 squared would be 4. Okay, so we have this data table, and we could create something that looks like that. That's exactly what we have, right? So you know how we get the data table by choosing some x values, any x values, finding out what the y values are, and then from that data table, we can create a graph. So if we were to look at this, we notice that our y-intercept is right here. When x is 0, y is 1. And so this is the basic shape of a graph that shows exponential growth, okay? You're going to notice that for this form, this y equals 2x, the y-intercept is always going to be here at 1. Get used to that because you're going to see some transformations. As we add or subtract things onto the backside here, you're going to see that graph move up and down. So let me show you that. If we had, let's just compare these. So if we had 2x plus 2, what do you notice about how the graph changes? You may be noticing that this y-intercept has gone up 2. That may be reminiscent of slope-intercept form, right? But you notice that our y-intercept is not 2. Our standard starts at 1, right? Our basic exponential equation has a y-intercept at 1. So when we add 2, that means we're adding 2 to that original y-intercept of 1. So our y-intercept is now going to be at 3. But it's going to take the same basic shape and show that linear growth. Let's look at another example. If we have y equals 2 to the x minus 3, you're going to notice that that y-intercept goes down 3 on the y-axis, okay? So our y-intercept is now here at y equals -2. So remember, you're going from 1, subtracting the 3 to find your new y-intercept. So as you make the matches, you're going to be double checking that y-intercept. You're also going to be noticing whether the 2 is positive or negative. And I want to show you a basic example of what happens when we have a negative in front of that exponential equation. It causes a complete reflection. And so here is that basic exponential formula. And this is the graph of what that would look like. You're going to notice that it is a reflection across the x-axis of the positive version. Okay, so I forgot where that went. There we go. Nope, that's not it. Oh well. All right, so it is a reflection. The y-intercept is right here at -1. And you are going to notice that if you were to create a data table, you could pick your values for x and say, I'm going to evaluate it at -1, 0, 1, and 2. And we would notice that -2 to the -1 power would be a -1/2. And we're noticing that right there, okay? We notice the y-intercept is at 1 because anything raised to the 0 power is just 1. And then we would have -2 to the first power would just be -2. -2 to the second power would be a positive That's not right. It's the negative stays there even though we square it, so it would be a -4. Okay, there we go. So we've got our data table. So I want you guys to play around with these, but I also want you guys to see, if we have these, how the graphs look as we play with the different structures. So here is a little bit different equation. Okay, now we're subtracting 2. I want you to predict in your mind what would happen to the graph here and how it would move. If you're thinking it's going to move down the y-axis, you are correct. And so that's where that's what that graph would look like there. Now, if we had one here and we said -2x plus 3, what would you expect that graph to look like? If you would expect this one to move up 3 units up the y-axis and look somewhat like that, you would be correct. So I want you guys to get used to seeing how those graphs transform based on what the structure of the equation looks like. So another way that you may see it is something like this, a verbal description. It's an x-axis reflection. So you're immediately going to know that it needs to be an equation that has a negative out in front of the 2x. The y-intercept is 0, 0. Okay, here's our basic equation. If we add 1 to that, would our y-intercept be at 0, 0? Yes, it would just move up one space up the y-axis. And so our y-intercept would be at 0, 0. Now, the next thing I want you to notice is the growth factor. And the growth factor just means what number is out here. What is that number? And that's 2, so our growth factor is 2. So that's all I really wanted you guys to see with these cards. But the more chances you have to put your hands on them and actually sort them out and make those matches and see if you can match all 3 parts: the equation, the graph, the table of values, and even the verbal description of it. It's just going to help you get used to seeing these transformations. It can seem a little daunting if you don't have a chance to just work with it and understand it and practice it. So I hope you're able to use that and find that helpful. Your job is to just write in the discussion what you noticed about how they changed and that you attempted the activity or know how to do the data tables matched with a graph, matched with an equation. Do you know how to do that? And tell me, yes, I know how to do that. Thanks so much, guys. Bye.